Hello all, in this video I'm going to show how can we use regression analysis in dynamic pricing. What is dynamic pricing? Sometimes you will see if you want to buy air ticket from say Chennai to Bombay, it might cost you maybe 7,000 rupees in one way. In another day, it might cost you 9,000 rupees. And another day, it might cost you 6,000 rupees. Why airline charge different price for different days or different time slot for different, though it is it is in the same route? The air travel, the price of these cases depends on the availability of the seat and the demand for the seat. If the demand for the seat is high, then airline charges higher fees or higher fare for the same ticket. If the demand for the seat is low, then airline charges a bare minimum base price for the airfare. So this kind of discriminatory pricing, often called in industry dynamic pricing, based on the demand and supply of the product or the service that are available. So in this video, I'm going to use cheese data set from Bayes-M package to demonstrate how can you use regression analysis for dynamic pricing. So first I will open my R. Okay, so first I'm going to call library Bayes-M. If you don't have this library, just please install this library. And in this Bayes-M package, there is called a dataset available called sliced cheese dataset. Okay. The reference is also available in Macula and Peter Macula and Peter Rose's Robert Macula and Peter Rose's book on account level modeling for trade promotion. And in this paper, this dataset first appeared. So first I'm going to call this dataset data cheese. So here you have the data set. So you have 4 columns: retailer, name of the retailer. There are about 88, it says 88 retailers. Los Angeles Lucky, Los Angeles Ralph's, Los Angeles Vons. So Lucky, Ralph, Vons, Dominique, these are the retailer chain, and this is the city name. So city name and retailer chain, they are different. And obviously, and then along with that, the volume or the unit sales, the number of volume sales that happened in that week. This typically called display activity that has happened, some marketing activity, they measured in the scale of 0 to 1. And the price, per unit price in US dollar is given. So the first thing I'm going to do, I'm going to take the retailer equal to check what are the levels that are available in cheese data set. So you can see there are 88 different retailer are available. So I'm going to say then, right? So these are the number of retailer is 88. Okay. Now I'm going to do some exploratory data analysis EDA for price to volume data to volume. So the first thing is plot cheese dollar price and cheese dollar volume. For each price, what are the cells that you see? And age equal to say 20 and color equal to sky blue. Okay, so it looks like this, that's how the price. And so X lab equal to price and Y lab equal to volume or unit cell, number of unit cells that has happened. Okay, let me just run it. And now, as I told you in a previous video, that if it is any economic variable, one should use log transformation. So I'm going to use log transformation over price and volume. And so it will be log price versus log volume. So looks like log price versus log volume has a sort of a expected slope, which is sort of fitting one line kind of thing, you see. And now so that means most likely log price to log volume, modeling log price and log volume will be much more effective than trying to do something different. So next what I'm going to do is say if you say retailer, so Albany price chopper, and so Albany is a small place, and we can have a look like maybe Los Angeles is a big place, so Los Angeles lucky, and they are also bit different places. So what I'm going to do is something like this. So first I'm going to make a subplot or subset of the data. So cheese, but it's only for the Albany. Okay, so the cheese data set dollar retailer equal to, so let me just copy this and comma. If I just do that, so these are the values of all the 61 observations, all belongs to Albany price chopper. Okay, and now what I'm going to do, I'm going to plot the points of only log cheese Albany dollar price comma log cheese Albany dollar volume and color equal to red and PCH equal to 20. So you can see the price is, these are the points which all belongs to price chopper. So chopper, Albany price chopper in this range. So you can give a different, for different price at different price level, the number of cells behaves like this. Okay. Now I'm going to compare it with Los Angeles Lucky. Let me see. Same thing, but instead of, I'm going to do it Los Angeles Lucky. Okay. Cheese LA. Now if you see, it also has 61 observations, volume, and these are the price and volumes. Now if I just do, instead of cheese LA, and instead of red, I'll use black, right? So all these are just different cluster altogether. So now if I fit a model here based on using all the models, then the line will pass through somewhere here. And if I use this line, right, because if I use all these points to fit a model, that line will pass through the middle of this, and that line will neither fit price chopper in Albany nor it will fit Los Angeles Lucky. So what we want a particular, for each retailer we want to fit a model. For each modeler we want to fit a separate model. So that's the idea. So what we will do, so that means there are how many retailer? 88 retailer. We want to fit 88 regression model. So let's fit 88 regression model. We will fit 88 separate regression model for each retailer separately. Correct? Now that's my goal. So first what I'm going to do, beta.ls equal to matrix NA, n row equal to n reg, and n col equal to 2. So this is my beta. I'm just creating a placeholder. This is just a placeholder, and call names will be, see, first is intercept, okay, and the second is log price. Correct? So what I'm going to do, these are the two things. So intercept and the coefficient of log price, these two will be stored, will calculate and store for all 88 retailers separately. So I'm going to fit 88 separate model for this. This is Los Angeles Lucky, I will have a separate line. This is Albany, price chopper, I will have a separate line. So we will fit a separate line for each of them. So what we are going to do now is, for I in 1 H2 nreg filter equal to cheese tailor retailer I, and then what I'm going to do, y equal to log of cheese dollar volume filter, and x equal to c bind 1 comma, this is essentially intercept or placeholder, and then this is log cheese dollar price filter, correct? And then beta dot ls I comma lm y tilde x minus 1 dollar coefficients. Now if you just say beta dot ls, these are the coefficient values of intercept and log price, coefficient of log price. So row names equal to beta dot ls equals to, you can put retailer, let me put retailer. So these are the names that we have for each guys. You have the retailer names. Now if I just put plot beta dot ls pch equal to 20, sorry, this is beta dot ls, yeah. So if you just, so these are the typical coefficients. There are two outlier and there is one outlier here. There are two different outliers, so we have to do a little bit of outlier analysis later. So now what I'm going to do, I'm going to try to answer following questions. Okay, how much, first question, how much surge in volume, surge in volume is expected if 5% discount on the current unit price, on the current unit price is offered. Okay, so this is the, if I give 5% discount on the current unit price, then how much surge I would, in terms of volume sales, I can expect. Then how much will be the effect in the revenue? How much will be the effect in the revenue? And what will be the effect of cost profit if cost per unit is $2. So these are the three questions we are going to discuss. Okay, so the first thing is unit cost is 2, right? Unit cost is 2, and let us take a retailer number is some number, maybe 8. Okay, now retailer number 8, who is this guy? Okay, Birmingham Kroger. Kroger is a big chain, and in Birmingham, Montgomery district or county, Kroger retailer. This is the retailer they are talking about. So let us have a look into the retailer summary. Typical, what is the summary statistics of this particular retailer? Okay, so the first thing I'm going to do is I'm going to take this guy's whoever this guy is, retailer with retailer number, right? And in that particularly I'm interested in 2 and 4, the volume and price. Particularly I'm interested in 2 reach to 4, volume, display and price. Why not I apply so this is the so first let me just take data sub. If I just say data sub data set, so this is the data set, and data set comma data sub comma 2 comma mean na.rm equal to true. Okay, and then if I just round up to 3 decimal places, so that gives me these values. So that means this particular retailer is selling at 2.386 on an average, the price that they are selling, and volume is they're selling about 1912 many units per week. So let me take the current price is this price, the average price as the current price. So this is suppose current price, okay, if this is the current price, and then I will call say current offer equal to 1 comma log equal to log of current price. So this is my current offer. Similarly, we have to make a alternate price which is, say, discount. We have to define a discount factor. So maybe 0.05% discount I'm giving. So whatever the current price times 1 minus whatever the discount factor. So the current price is 2.386 after giving, say, 5% discount. Alternate price is 2.267. Now, so my alternate offer is 1 comma alternate price. Okay. So the first thing now I have to do is beta hat equal to beta dot ls retailer equal to retailer number. So if I just take, so this is my coefficient for this particular retailer. Okay. Now volume, if for this current offer and alternate offer, what would be the volume, expected sales of the volume? That is clearly current offer beta hat percentage star percentage beta hat, and then you have to make expected, because remember that we are fitting log volume versus log price. So volume current sales. Okay. So this is you're expected to make a sale of 1883. Now similarly I can also make prediction for the alternate offer. So alternate offer okay. So this is my current offer, this is my alternate offer. Okay. So alternate offer minus current offer divided by volume of current offer times 100. Okay. Let me just do one thing. Percentage star percentage. I think I'm making 7.75, right? 267. This seems very different. Internet minus volume current. Okay. So let me just take this volume change. Maybe there will be a serious drop in the volume. I think that we can take it as at face value. And we can compute the expected revenue. Expected revenue. Yeah, okay. Expected revenue is whatever be the retailer summary, and that's the volume times retailer summary of the price, right? So this is the volume that you expect. Okay, so we can call it current expected revenue. Okay. Okay. Now what we will do is we will check what would be the changed revenue. The change revenue will be, first we have to take this times 1 plus whatever the volume change divided by 100 times unit cost, right? That will be the, sorry, that will be not unit cost, that will be alternate price. That is the that will be the, so the expected revenue is 4,562 and the change revenue is, sorry, 1000 something, 1023, right? So this is sort of a names of change revenue is updated expected revenue. Okay. Now total cost will be whatever the volume times this changed percentage times unit cost. So this will be the total cost and change revenue is this, so this will be the total cost, and profit would be changed revenue minus cost. So the total profit will be $120. Okay, from this one particular guy. So now what we will do, we will put it into sort of a, we have to do this calculation for all the retailer. For do this calculation for all the retailer for I in retailer. Okay, so the first thing I have to do is perhaps data sub and retailer sum. Right. Okay. So retailer summary, and let me just run this part. Let me see if this is coming properly. All right, I comma yeah, so it is. All right, that's happening, that's fine. So now what we have to do, we have to just take the current price. Retailer summary is done, right? And then we have to just take current price. So let me just check if it is doing well. Yeah, okay, fine. Now what I'm going to do is I'm going to calculate the current volume and the expected volume. These things will be exactly same actually, no change. So this will be, there will be no change. But so now what we need a, essentially I need a discount factor. So discount factor is here actually, you know. So let me just take these things, two things. So I don't need this, unit cost is 2 retailer, and then essentially I need result table. Okay, result table data dot frame matrix na n row equal to n reg and n call equal to 5. Okay, and call names equal to result table equal to C. First is current price, second is alternate price, third is change in expected revenue, how much change we are expecting, total cost, and final profit. Okay, all right. So now if I just run it, and result table equals to, I have to do one more thing. We have to do, that is call names. I have to do row names also. Row names result table equal to retailer. Right. Okay. So if I just now define it, you can see all these names are there. I have just created a placeholder for that. Now result table equals to I comma C. So what I have to now fit is current price. What is current price? This is the current price. Then alternate price. Then current price, alternate price, change in expected revenue. So changed revenue. Then cost because of the change offer, and what is the final profit. Okay, so let me see. All right, let me just run it. Okay, now here is the things. Okay, do one thing, boss. What I'm going to do is round it off to cost. I'm going to make it round it off to 2, and profit also comma 2, and changed revenue equal to change round it off to 2. Okay, so let me just run it once more. Looks like fine. Okay, here is the, for Charlotte below there is a huge profit that are coming up. Below is also giving us quite a bit of huge profit. So there is something to do with the below, Charlotte and South Carolina. Why it is, I don't know. Maybe there could be some issue with the coefficient. Remember that maybe these is one of the outlier coefficient that is getting reflected. But if you now, instead of 0.05, if I just give 1% discount, well, let's see what happened. You see, okay, so what I'm going to do is result table is dollar profit, kind of median profit. What is my median profit from a $58? Okay, so that makes sense. Perhaps if I just give 1% discount, my median profit is $58, and total profit of, if I give this to everybody, then this is my huge profit, or maybe I'm just getting, I can give, max profit that can I get is, this is a big number. This is definitely not right, something wrong. And then if I give, say, 10% profit, 10% discount, then what happens is median profit is 64 and maximum profit. So I think I'm pretty much, so this particular guy, whoever this is below, Charlotte below. Let me just take copy and beta dot ls. Yeah, so 1.27 is somewhere here. No, yeah, and 7 point something on the lock price. So this is definitely one, these two guys. Here is, I'm pretty sure these two guys here is giving us the problem. So if I just put it there, yeah, 0.96 and 9.5. So my lock price, the coefficient is 9.25. So most of my coefficient are negative, you see, most of the coefficient, but this guy is giving me very large positive coefficient. That means, and intercept is 0.96, which is near 1, whereas most of the intercept is near 10, at least above 5. So this tells us these two estimates for South Carolina below. Maybe what I will do, I will do a plot. So in this, let me just draw a plot. So here is the plot, here is the Chinese cheese data set for Albany, Chopper. This is our LA, Los Angeles. This is SC below, South Carolina, and this is South Carolina below, right? And then if I just plot that guy, cheese SC versus cheese SC, and instead of black, maybe brown. Okay, let's see where this guy is. Yeah, you see, this is the problem. All points are here, and that's why. So there is no diversity in the points. All points are plotted here. That's the issue. So, or I can just say blue. Let me see if I can show you guys. Yeah. See, all points are in one line, and as a result, probably the line is very sharp. So these kind of weird point set of points, if you get, you can't do much. Effectively, you can't do much. You have, yeah. One possibility is you can try some Bayesian, hierarchical Bayesian models, but that is bit out of the question here. But we will see if we can fix it. But I hope you understood what is happening. So if we, even if we decide to, okay, let's drop these two guys. Okay, we have this, if we drop these two guys for the time being from the, so what are those two names? Let us see. One is Charlottesville below, and the other guy is other one where we got a terrible estimate is South Carolina below. So this two retailer, I think, have some issues. So what we are going to do, we are going to result table minus these 2% result table. Now if I just run this, I'm not sure if we can drop it in this way. All right, so it's not, looks like it's not mutable. Oh, okay. If I just drop this guy like this, invalid line argument, okay. What I can do is so I just, why not I do this? Just for the time being, I can come up with a much better index index of retailer equals to Charlottesville which 15 and so x and then equal to c text comma South Carolina below. So these are the two cases, and then result table minus index, if I just say that. And now if you see, I have dropped these two guys kind of. Now what is happening is, if I now median profit and this is the max profit, and sum if the result table and dollar profit is this, right? Now if I just go and say 0.01%, if I give 1% discount, then median profit is 56. Let me just start with no discount. So I'll not give any discount. Current price, my kind of median profit is 55. Max I can earn 841 from one particular retailer, and total profit can be expected to $9,814. Now if I give a 5% discount, then it is median profit sort of increased 59,717. Actually, let me just do one thing. Let me not print this line, otherwise it's creating a lot of ruckus. So let me just create another thing. Okay, if I don't give discount, then that is what happens. So discount 0, discount equal to 0, I get median profit of these guys. Now if I give 5% discount, then I get this. Discount is 5%. Now my total profit reduce a bit, and then if I give 10% discount, my median profit increases probably to 62, but total profit drops. So total profit drops, max profit drops, but overall drops. And then if I just say this of result table dollar expected revenue, change of expected revenue. So at 0 discount, what happens is my total revenue is $39,000. When I'm giving 5% discount, my total revenue is $46,000. My total revenue goes up from 39,000 to 46,000, but total profit came down from 9,800 to 9,700, but median profit raised by $4. Okay, median is the 50% rate at a lower level, overall profit goes up. And then what happened that when I give 10% discount, at a 10% discount, so revenue I expect will go up further, but profit may not go up. So the median profit again goes up, but total profit goes down, but the revenue goes up quite significantly. Discount is 10%. So total profit going up to from 46,000 to 54,000. So total revenue shoots up, but total profit goes down marginally. So sometimes the company wants to show grab the market share, and in order to, if they see that if my total profit is not taking hit but my overall market share is going up, why not I give some kind of promotional activity by giving discount. Now based on this is like giving overall, but at the same time what people can do, they can check where overall profit going up and where the profit is not going up. Where the profit is not going up, they can, like here in this New England North shop-in, if the profit is negative, then they should not give the discount here. Okay, or anywhere if the profit is less than certain value, they will not get profit discount, otherwise they will get a discount. So this kind of discriminatory pricing practice sometimes helps companies to improve their profitability. So I will stop here. I hope you enjoyed that how simple predictive model and regression analysis can help companies and industry to implement dynamic pricing and improve their profitability improve the total revenue, and maintain the cost at bay. We will continue with such more data analysis in the next few videos. Thank you very much. See you in the next video.